Here we are in the second video of this series, and notice on these slides, um, for the learning outcomes, I put the section number. If I go back, I put the section number at the beginning. If I put the section number at the beginning, this information is in the textbook. I added some framework to this lecture, that I added some ideas that aren't directly in the textbook. They are, but I kind of organized it in a way that's not done the same way in the textbook. So you'll notice that there's not a section number. So this is not directly from the textbook. Don't expect to find chain of infection in the textbook. You're going to find all the links to the chain, but you're not going to find this terminology. I think this visual helps understand these concepts. Otherwise, the book's kind of presenting them all separately without connecting them like this. And I think it just makes it harder to remember. So I want to talk about this concept of the chain of infection and the importance in breaking the chain. And so when you're looking at a pathogen that's going to cause disease in an organism, here we have there's an infectious agent. It has a reservoir, a portal of exit. All of these have to be intact. All of these have to be something about that organism and connected in a way that allows the organism to cause an infection. For example, the idea is, in order to stop the infection, we've got to break the chain. So somehow we've got to stop the organism from entering the host. So we've got to disrupt the portal of entry, or we've got to prevent it from being transmitted. And so we're going to talk about each one of these links and how they all contribute to infectious disease. And as you look at those, it also gives us ideas on how to prevent infectious disease. So you'll get a feeling for that as we progress. So here we are in section 11.2, differentiate between a microorganism's pathogenicity and its virulence, and explain the concept of an opportunistic pathogen. Why am I doing that? Because we're going to start on this first link. We're going to talk about the infectious agent. We're going to talk about what's the organism that causes disease and how is it causing disease. So we're going to start off with this first link, our infectious agent. So here's some vocabulary. When we're looking at a microorganism and we want to know about its pathogenicity, what it means is the organism's potential to cause disease. And this is just a yes or no. Is it a pathogen or is it not a pathogen? Is it able to cause disease? And your textbook gives you a couple vocabulary words. They give you the term true pathogen. I've never really used that term, but I would just call it a pathogen. But they use true pathogen, which they mean a microorganism that can cause disease in a healthy host. So that's most pathogens can cause disease in a healthy host, as compared to an opportunistic pathogen, which is a really common term, which only causes disease in an immunocompromised host. And you can think of examples of that when you're looking at, for example, we mentioned thrush a while ago, and the host, the person that gets thrush, has some imbalance in their microorganisms, or they're an infant. They don't have very good normal microbiota. Somehow they're immunocompromised. It's an opportunistic infection. People that get Clostridium difficile are usually older. C. diff, Clostridioides difficile, are generally older. They've been on antibiotics. Their immune system might be weakened. Their normal microbiota might be disrupted. Think about HIV infection. When people get HIV and AIDS, some of the real triggers to us recognizing that there was this new disease is people were getting certain kind of lung infection or other infections that weren't that common. And it turned out people became susceptible to certain opportunistic pathogens that don't make healthy people sick. But they were making these these HIV infected people sick because they were immunocompromised. So opportunistic pathogens are pathogens, but they're not very strong pathogens. So the way that we describe the strength of a pathogen is its virulence. So we would say an opportunistic pathogen has very low virulence, a very low ability to cause disease. Okay, so its virulence is kind of the degree of pathogenicity. So we'd say it's either a pathogen or not. It's yes or no. Its virulence is going to be the degree of pathogenicity. So once again, a true pathogen is going to be more virulent than an opportunistic pathogen. An opportunistic pathogen is only going to make people who are already weakened sick. Get me out of here. Okay. Use appropriate vocabulary to describe types of infections, including local versus systemic, focal, polymicrobial, primary versus secondary, and acute versus chronic. And so sometimes it helps to put pairs of words together. This table is exactly from your book. So if we compare local or localized versus systemic infections, I bet you could do that without even reading this. A localized infection is going to be when the microorganisms enter the body and they colonize a specific tissue and then they stay there. And so here's some examples. Boils, which are a lot of times caused by Staphylococcus, warts, that kind of thing. So something that, and even we just get a cut and the cut might get infected without spreading through the body. A systemic infection, one that spreads to several sites and tissue fluids, and usually it goes through the bloodstream. So, we're cautious about pathogens entering our bloodstream because that means they can become systemic and go anywhere. And a lot of the infectious disease we get are systemic. A lot of times people think like chickenpox, oh, it's in your skin, it's local. But actually, you've inhaled the virus, it's spread through the body, and some of the appearance of the infection is showing up in the skin. But it's actually an infection that's been spread through the body. So a lot of these infectious diseases we get cause systemic or system-wide infections. Focal infection, when the infectious agent spreads from a local site and is carried to other tissues. And I like the example that they give of a focal infection because we know that when people get gum disease and they have an infection in their gums, those microbes, remember a lot of microbes grow in biofilms, they can fall off or kind of dislodge from that biofilm, get into your bloodstream, and then spread to other parts of the body. And a lot of times we're concerned about people that have damaged hearts getting infections from their gum disease. So a focal infection is an infection that results from a local site spreading to other parts of the body. And so what you have to do here, you have cardiovascular disease. You're having a problem with the cardiovascular infection now, but you have to go back and deal with that, the original local site to eliminate that infection. Mixed infection or polymicrobial infections. This is actually something that's relatively new, and the study of the human microbiome and the technology used there has really helped us understand more about polymicrobial infections. What that means is when you have an infection that is resulting and that the disease is caused by multiple microorganisms. So several agents establish themselves simultaneously. One of the things that people were surprised to find out again, in the past 20 years was that a lot of ear infections, how a lot of little kids will get ear infections. The bacteria come from their respiratory tract up their auditory tubes into their middle ear. And so a lot of times these are polymicrobial infections. There's more than one kind. And so you give them an antibiotic that kills one kind of bacteria, but it might be caused by two kinds of bacteria. And these can be complicated infections. And these are much more common than we used to believe. Here it's wound infections, bite infections, things like that can be these polymicrobial infections. So just treating one microorganism might not be enough. Here we have a primary versus a secondary infection. The primary infection is going to be the initial infection, can be anything. And a secondary infection is going to be caused by a different microbe. So a common thing that I think of a lot is a lot of people will get the flu and or get a cold. And what can happen is, the flu is caused by the influenza virus. Well, you get a flu, but what it does is it weakens your respiratory tract, and the coughing or just the irritation of your lungs can cause problems that make you susceptible to a different pathogen. And so it says often a result of lower host immune defenses. You've been fighting this infection. Well, what it does, it makes you susceptible to a second infection. So you get the flu, but then you get bronchitis from bacteria. And so the flu would be the primary infection, the bronchitis would be the secondary infection. And so sometimes we have to be really careful when people are sick with the primary infection that they don't open themselves or make themselves receptive to another pathogen and get a secondary infection. Here you go, common cold complicated by otitis media, an earache. Okay, so your immune system's under stress fighting the cold, and pathogens can, from the coughing and possibly pushing fluid into your middle ear, along with bacteria, cause an earache. And then the last pair of vocabulary, acute versus chronic infection. An acute infection, and this is most of what happens with our infectious disease. You get an infection, it comes on rapidly, and you get signs and symptoms of diseases, and you get sick, but then it's short-lived and goes away. So, anything, influenza, cold, that kind of thing. Whereas a chronic infection is going to be one that progresses over a long period of time and won't go away without treatment. And even in that case might not go away. So HIV is a good example, but even syphilis, is going to be a chronic infection unless it's treated. There's a lot of infectious disease that will become chronic if it's left untreated. But most of what we're familiar with are acute infections, the one that come on fast and go away naturally. Okay, the next one, again, more vocabulary. I use the term signs and symptoms of disease. And so when we're talking about a sign of disease, it's something that can be measured by somebody that's not you. So somebody can, if you look at all these, here's some influenza signs and symptoms. They can measure a fever. Someone else can measure or they can assess your cough because they can see it, but they can't. And so these would be considered signs of disease. A rash would be a sign of disease, and different kinds of rashes are indicative of different kinds of infections. Whereas symptoms are more so only you can describe it. So you have a headache, you have body aches, those kinds of things. And so we use a lot of that to identify what is that causative agent, what's causing our disease. There is in the practice question, there's a whole thing about signs and symptoms that you can practice. And there's the answers, but I also have the answers in your study guide. And let's see, here we go. We have explained the common ways microorganisms can damage their host. And I think this is an important concept because we just think, oh, you get infection and you get sick. But really, when you think about it in more detail, it's like, well, why do you get sick? What's going on? And this diagram's from your book, and I'm only going to cover two of these because this one with the epigenetic changes, that gets pretty complicated, and I think you can get get an appreciation for this without going into that amount of detail. But There's actually a couple major ways. I mean, microorganisms are going to grow in the body and they're going to potentially damage tissues. But the one of the probably the most common way that they damage tissues is it says they secrete enzymes and toxins. And different enzymes can do things like break up the connections between cells or break red blood cells up. There's all sorts of enzymes that bacteria produce, and they can cause damage to our cells. There's also some special toxins. The toxins are called endotoxins and exotoxins, and I'm going to go into more detail about that. But some bacteria produce toxins. They're poisonous substances that cause damage, direct damage to our cells. And some of those toxins are what we see as signs and symptoms making us sick. But the other thing that microorganisms can do and can have life-threatening impact are triggering the host to do damage. And so sometimes what happens is when certain bacteria get in our body or viruses, our immune systems kick into protection phase, and they're going to promote fever. It's going to promote inflammation, and sometimes our immune systems overreact in response to bacterial infections. You might learn in other classes things about septic shock and organs shutting down in response to a bacterial infection, and that's an overreaction of your immune system to an infection. So getting a systemic infection and causing your immune system to overreact can be a very serious impact of having a bacterial or viral infection. So host defenses can also do damage. In this slide and in your book, there's a discussion on endotoxins and exotoxins, but I think I'm going to put that in the next video.